Hello and welcome back to Chapter 2 of Unit 4 of the Advanced Java course. In this chapter I'm just going to teach you about recursion and heaps, which are key to learning more efficient sorting algorithms. So recursion is a very powerful technique when you can't really use a simple loop, or it's more complicated than a simple loop. A recursive method is something that calls itself. It uses its own logic, right? And you can use it to break down tasks into smaller, more repetitive tasks. It's also useful when you require values that use the same logic to obtain previously. So a simple example to understand what recursion is the factorial method. So a factorial of a given integer is a product of the integers and every integer preceding it, right? So 5 factorial is 5, and then 5 times 4 times 3 times 2 times 1 all the way to 1, right? So if you generalize this recursively, you can see that n factorial is basically n times the factorial of n minus 1. So the factorial is recursive because it defines itself using another factorial with it, right? So 5 factorial is 5 times 4 factorial, and then 4 factorial is 4 times 3 factorial, and so on and so forth. Another example you could use is called the Fibonacci sequence. So let's just quickly look at a factorial program to see how recursion really works. So here I've imported scanner, and I'm going to use system.out.println to output data. Scanner is just a method so you can input data via text by typing. So I'm going to use long n equals s.nextInt to receive the input. We're going to use the data type long because because factorials can get pretty large pretty quickly, so we're going to use long to help us see factorials like really large factorials like 100 or so. So then we're going to use an if statement to define the factorial. So if n is less than 1, or less than or equal to 1, then it will just return 1. Keep in mind this is what you call a base case, because if there was no base case it would just go ad infinitum, right? So you have to have a base where to the point where it stops, because it'll go to something really complex down to a lot of base cases. So you need a base case. So if it's not, then it will just do the regular factorial method that I showed you, translated into Java. So so as you can see, both of them are using the same method, and that's basically recursive notation. And it receives the parameter n. So n is the factorial we're trying to use. So if we do 5 factorial, it would do 5 times factorial of 4, and factorial of 4 is 4 times factorial of 3, and so on and so forth. So if we just test this and run it, we're going to do factorial of 5, and as you can see it's 120 on the bottom. So it works. So that's just recursion in a nutshell. So now we're going to move on to heaps. Heaps are basically a type of tree data structure used in programming. And a tree data structure is just a way to sort data. So each tree starts at what's called a root, and these lead to other nodes. So nodes that branch off into other nodes, these branched off nodes are called children, and each of these connections is called a branch or edge. And any node that doesn't have children associated with it are called leaves. And so a heap is basically a tree when each node is greater than or equal to each of its children. So for example, in this heap structure, we have 18 and then 12 and 7. 18 is greater than both, so it does satisfy the heap property. But if you go down here, you'll see that 10 is not greater than its child 12, and so this does not satisfy the heap property. So a tree is a heap if all of the nodes satisfy the heap property. Now we're going to move on to some of the properties of heaps. So a tree with one node is always a heap, and a heap is constructed by adding nodes. And nodes are added to the rightmost node starting at the lowest level. And if the lowest level is full, then you can start a new level. So to make a heap into an array, you just need to simply start at the root and go through each level in order. So we start at 36, 20, 28, 7, 3, 16, 9, and on to the new level. Just remember, in an array, you have to start with the index of 0. Now I'm just going to show you how to maintain a heap. So if a node does not have a heap property, just change it, exchange it with a child of greater value. So in the example I showed you earlier, this tree did not have a heap property because 12 was greater than 10, so all we had to do was just exchange it to maintain this heap property. So that's it. Recursion or heaps are pretty powerful techniques, and it'll help us learn how to create the heap sort algorithm, along with some other sorting algorithms associated with it.